Sometimes late at night, when the lights are low and the room feels like a small, quiet universe of its own, I like to play a little game with myself. I sit still, close my eyes, and try to imagine that the air around me is not really still at all. I pretend that the walls, the floor, my own body are all floating gently on an invisible ocean that is always moving, always trembling. Even when I feel nothing, I imagine that this ocean is space-time itself, the fabric of reality, stretching and relaxing, like the surface of a calm, dark sea after a distant ship has passed. And then I ask myself a strange question. What if right now, some unimaginable collision a billion light years away is sending tiny ripples through this room, through my body, through my thoughts, and I just don't feel them? I don't know why, but that thought always makes the night feel deeper, like the darkness has more layers. It makes the quiet sound different too, like there's a soft, secret music playing far below hearing. I sit there and listen, knowing there are no drums, no strings, no voice, just this silent shaking of reality itself, so small that it slips right through me without a trace. But still, I imagine it. I imagine that if I could slow time down enough, if I could make my senses 1,000 times sharper, I might feel the room breathe in and out, the way the floor shifts by less than the width of an atom, as a wave of nothing and everything passes through. The idea that space and time themselves can ripple started, for me, in a very human way. Not in a lab, not in a textbook, but in a memory of standing by train tracks as a kid. I remember the smell of rust and old wood, that sour metallic taste in the air, the gravel crunching under my shoes. I remember how the rails would start to hum before I ever saw the train. The sound would rise slowly from silence to a low song that I could feel in my chest. The ground would tremble just a little, like a nervous heartbeat. And then suddenly there it was. The train exploding into view, wind slapping my face, the smell of oil and hot steel rushing over me. And then it was gone, leaving only the shaking in my legs and the echo in my ears, the air still buzzing with the memory of motion. Later in life, when I first heard someone describe gravitational waves as ripples in space-time, I didn't think of equations or diagrams. I thought of those train tracks humming before the train arrived. The world announcing something was coming, not with light, not with sound, but with motion itself. The idea that space could shake, that time could shiver, felt like a secret that had always been there, just waiting for someone to notice. We live in a universe where collisions are not accidents, they are part of its heartbeat. Stars crash into each other, black holes spiral together and merge. Whole galaxies pass through one another like ghosts, their stars mostly missing each other in the vast emptiness, but their shapes twisting and stretching like two clouds of glowing milk mixing slowly in the dark. And each time a huge collision happens, space-time itself feels it, like a drumhead being struck from the inside, sending ring after ring of ripples outward, racing through the dark at the speed of light. The strange thing is, we are floating in those ripples all the time. Right now, as you listen, tiny waves from long-dead collisions are passing through you. They don't shake your chair. They don't rattle your bones. They're too small for that, too gentle. They stretch you one way and then the other by such a tiny amount that your body doesn't even notice. Your heart doesn't skip. Your breath doesn't change. But your atoms know. Your atoms feel everything quietly. I like to imagine them as whispers moving through glass. The glass does not shout about it, it just lets the whisper pass. The first time humans heard these whispers, really heard them, it happened in a place that, from the outside, looks almost boring. Long, straight tunnels in the middle of quiet land. Mirrors, lasers, pipes, cables, computers. Nothing that glows like a star or roars like a rocket. Just long, empty arms of vacuum, stretching out in a perfect L shape, 4 kilometers one way, 4 kilometers the other, lying flat on the earth, like a simple drawing a child could have made. It's called LIGO, a name that sounds small and soft compared to what it actually does. Inside those tunnels, laser light bounces back and forth between mirrors, over and over, like a beam trapped inside a hall of glass. The idea is simple in spirit. You split a beam of light into two parts, send them down those long arms, bounce them off mirrors, and bring them back together. If space-time itself stretches or shrinks along one arm more than the other, even by a distance smaller than a proton, the recombined light will change its pattern just a little. It will flicker in a way that says something passed through here. Something shook the fabric we're made of. Sometimes when I think about that, I picture the people working there, walking along those tunnels, hearing only the soft buzz of machines, smelling dust and metal and coffee from some break room nearby, their footsteps echoing faintly on the floor, not knowing that at that exact moment, a wave born from the death dance of two black holes 1 billion years ago is quietly stretching and relaxing the building around them. I imagine someone checking a screen, maybe yawning, maybe thinking about their dinner, unaware that the universe has just tapped them on the shoulder. The first big tap came on a day in September 2015. But really, the story started more than 1 billion years earlier, in a place we will never see with our eyes. Two black holes were circling each other. I like to imagine them not as cartoon holes in a sheet, but as dark, heavy hearts, invisible but enormous, locked in a slow, spiraling dance. Around them, space was curved like water pulled into a whirlpool. Time itself was running slower near them than far away. And as they circled, they were losing energy, not in light, not in heat, but in ripples of space-time, waves expanding outward in every direction. For millions of years, they circled, coming closer, their dance speeding up. The ripples grew stronger, like music growing louder as the last notes approach. If you could have stood safely nearby, which you can't, you might have felt reality itself vibrating under your feet, though your brain would have no words for it. Then, in a final wild moment, they merged into one. The collision released more energy in those few seconds than all the stars in the visible universe shining at once. But almost all of that energy did not become light. It became waves in space-time, racing outward like the last huge rings from a stone thrown into a black ocean. Those waves traveled across the cosmos, passing through galaxies, through clouds of gas, through empty voids so bare that a single atom might drift alone for years before meeting another. They passed through places where alien suns burned, where planets spun, where maybe someone, somewhere, looked up at the sky and wondered if they were alone. The waves didn't care. They just moved, silent, unstoppable, neither slowing nor tiring for over 1 billion years, until one thin front of that ancient storm finally brushed past a small blue planet and then slid through a long, quiet tunnel of metal and light. In that moment, as the wave passed through LIGO, the distance between its mirrors changed by less than 1,000th of the width of a proton. The change was too small for human hands, human eyes, human nerves, but not too small for light. The returning laser beams no longer lined up quite the same. The pattern on the detector shifted. On a screen, a faint signal rose out of the noise, a tiny curve, a quick chirp when turned into sound. And there it was, the universe speaking in ripples, and us at last listening. I remember the first time I actually heard that sound, this tiny whoop, like a drop of water falling into a quiet pond, but sped up to be heard. It was so short, so soft, and yet it carried with it the weight of 2 black holes, 30 times the mass of our sun, smashing together. I felt a chill in my skin, like standing near a window in winter. Not because the sound was scary, but because it made distance feel different. That little chirp was not a local sound. It was the echo of a collision that happened before humans existed, before Earth had its current shape, before so much of what we think is old was even born. Listening to that chirp was like standing by those train tracks again, feeling the ground shake from something I couldn't see yet. Except this time, the train had already passed 1 billion years ago. I was only now feeling its echo. What moves me most is not just the physics of it, but the feeling it gives about connection. A black hole merger in some forgotten corner of the universe bends space-time. That bend spreads outward. It passes through galaxies, through empty space, through us. It passes through your body, through your bones and blood and thoughts. And yes, it is too tiny for you to notice. But it still happens. You are not separate from these events. You are a part of the same fabric that is being shaken. You are not watching the universe from the outside. You are inside the ripple. Sometimes I think about how strange it is that we've always been inside these waves, but only recently built tools delicate enough to feel them. It's like living your whole life next to the ocean and only learning very late that the soft rumble you heard through the walls at night was not the refrigerator, not the pipes, but the waves on the shore. Suddenly, the world outside your house becomes bigger, and the sound you ignored becomes a message. Gravitational waves, these space-time ripples, are different from the light we see with our eyes or with telescopes. Light can be blocked, absorbed, scattered. Dust clouds can hide whole stars. The core of a collapsing star is wrapped in layers and layers of matter that light struggles to escape. But gravitational waves pass almost untouched through everything. They don't care if there is 1 billion kilometers of rock in the way. They don't slow down for gas or dust. They don't bounce off walls. They move through planets like planets are smoke. That means they carry stories from places light cannot escape. When a massive star dies and its core collapses into a black hole or a neutron star, the inside of that process is hidden from us by thick layers of burning and falling matter. We see the flash, the explosion, the afterglow. But the heart of that collapse is like a secret room with no windows. Gravitational waves are, in a way, the faint vibration of the walls when something huge happens inside that room. They are not detailed photographs. They are more like the feeling you get when a neighbor slams a door and the floor shakes. But even that feeling tells you something. Someone is there. Something happened, and it was not small. I remember once sitting in a very old house with thin walls and wooden floors. At night, you could hear everything. A door closing 2 rooms away, a cup set down on a table, the pipes clicking as the water cooled. Sometimes lying there in the dark, I would try to guess what was happening in the other rooms, just from the vibrations and sounds. A chair scraping, slow and careful, footsteps pacing, light and quick. A muffled laugh. You couldn't see any of it, but the house carried it to you. The universe is like that house, but instead of wood and nails, it's made of space-time. Instead of footsteps and doors, it carries the shutters of stars and black holes. And now, with instruments like LIGO and Virgo and others around the world, we're pressing our ear gently against the floorboards of reality, trying to make sense of the faint tremors moving through it. Of course, the waves we can currently hear are only the loudest ones, the ones born from huge, violent collisions. Binary black holes. Neutron stars spinning together like a pair of cosmic ice skaters locked in a final embrace. These are not gentle events. They are the universe at its most intense, matter and gravity pushed to their limits. But I sometimes wonder about all the quieter waves, the ones too soft for us to feel yet. The slow, deep ripples of the early universe itself, from when everything was young and hot and dense, like a cosmic soup just pulled from the fire. There is a theory that right after the Big Bang, the universe went through a phase of extremely fast expansion, stretching, ballooning, growing from smaller than an atom to the size of a galaxy in a fraction of a second. If that happened, it might have left behind a faint background of gravitational waves, a soft roar under everything, like the sound of distant traffic you only notice when the room is otherwise silent. If we ever listened gently enough to hear that hum, it would be like touching the universe's baby picture, not with our hands, but with our understanding. To me, the idea that the universe has a background music made of space-time itself is one of the most beautiful things science has ever suggested. Not because it's poetic, though it is, but because it makes our existence feel both tiny and deeply connected. We grew up, as a species, listening to the sounds of our own world. Wind in trees, waves on rocks, voices in caves and streets. Then we built radios and began to hear invisible signals, voices from across oceans, beeps from satellites, static from the sun. Then we built telescopes and saw light from galaxies so far away that their light left them before Earth even existed. And now, we are finally starting to feel the tremors of reality itself, the way you feel the bass of a song through your chest, even when you can't hear the words. I think about someone sitting alone in a control room at one of these observatories. It's late, the coffee is lukewarm, the screens cast a soft glow over their face. Outside, the land is quiet, maybe a little fog hanging low over fields or hills. The air smells like dust and night and machines. On the monitor, there's a line, mostly flat, little squiggles of noise. Then, for a fraction of a second, the line curves in a way that matches a pattern they've been waiting for. A message from colliding black holes, or from neutron stars tearing each other apart. In that tiny loop on the screen, there is a whole story. Two objects orbiting each other for millions of years, giving up energy, coming closer, their orbits tightening, their speeds increasing. It's like reading the last sentence of a very long book and knowing that the rest of the pages exist even if you cannot see them. When neutron stars collide, it's different from black holes. Neutron stars are incredibly dense, like city-sized balls made of the tightly packed cores of atoms. They are made of matter, pushed to a state we cannot create in any lab on Earth for more than a moment. When they spiral into each other and merge, they produce both gravitational waves and light. In 2017, we caught one of these events. First, the space-time ripple arrived. A little later, telescopes around the world saw the afterglow in light. Gamma rays, X-rays, visible light, radio waves. It was like hearing a distant drumbeat and then seeing the flash of fireworks in the same direction. From that single event, we learned that these collisions make heavy elements, like gold and platinum, the same gold people wear on their fingers and necks, the same platinum in electronics, likely came from such cosmic crashes. I remember holding a simple gold ring once, feeling its smooth, cool surface against my skin, and thinking, somewhere, billions of years ago, two dead stars smashed into each other and threw this into space. Those gravitational waves that rippled out from that collision passed through everything they met. Maybe, long before any human existed, those waves passed through the gas cloud that would one day form our sun, our Earth, and eventually us. The gold sank into forming planets, into rocks and ores, into rivers and mountains, until someone dug it up and shaped it into a circle and slid it onto another person's hand as a sign of love. A love story rooted in a star collision. A promise ring forged in space-time fire. It's almost too much to hold in your mind at once. I find it strangely comforting that so many different scales of reality are connected by these waves. On the largest scales, whole galaxies dance and merge, sending out slow, deep ripples that we might someday feel with even more sensitive detectors. On smaller, more violent scales, black holes and neutron stars smash together and ring like bells, sending faster, sharper waves. And on the smallest scale, inside us, our bodies are full of tiny movements. The beating of our hearts, the flow of blood, the firing of neurons, the jostling of molecules in our cells. These are not gravitational waves in the same sense, but they are still waves in a way, still patterns of motion in a medium. We are made of motion. Even when we sit very still, our atoms vibrate. Electrons dance around nuclei, quantum fields flicker in and out of existence. Stillness, when you zoom in enough, is just very organized motion. So it feels fitting that the universe itself also never truly sits still. Space expands, time flows, space-time ripples. Somewhere, always, something is colliding, and that collision is announcing itself, not by shouting in light, but by nudging the fabric of reality, a tiny, precise nudge that travels forever. Sometimes, though, I also feel a kind of tenderness toward the things we cannot yet hear. There are collisions happening right now that send waves too soft for our current instruments. There are perhaps entire populations of objects, small black holes, strange compact stars, or something we haven't imagined, that are making patterns in space-time that we are still deaf to. It's like knowing there is an orchestra behind a wall, and you can only hear the loudest drums. You know there must be violins, flutes, quiet notes. You can feel their absence like a missing color in a painting. We build better tools, not just to be clever, but because we are curious about these missing notes. We want to know what else is playing in the cosmic music. We want to know if there are faint waves from the early universe, from cosmic strings if they exist, from primordial black holes if they formed shortly after the Big Bang. The ideas may sound exotic, but at their core, they're all about the same thing. The universe leaving fingerprints on space-time and us trying to find them. There's something deeply human about listening for distant collisions we will never see. It reminds me of listening at night, in a quiet house, trying to guess if the wind outside is just wind, or if maybe it's a car passing by, or a branch scraping the window, or rain beginning to fall. We have always used sound, vibration, to extend our awareness beyond what we can see. A knock at the door, thunder beyond the hills, the crack of ice on a frozen lake. Now, on a completely different scale, we're doing something similar with the universe. I wonder how it felt long ago for someone to hear thunder and not know what it was. Just a distant boom, a shaking in their chest, a light in the sky, and no clear reason. Maybe they felt fear. Maybe they felt awe. Maybe both, mixed together in a way that made their hands shake. Over time, people learned to predict storms, to understand lightning. The fear changed shape. It became respect, caution, maybe even appreciation. The unknown turned into a pattern. With cosmic collisions, we are somewhere in the middle of that journey. We understand a lot about gravity and orbits and black holes. We can write down simple formulas that tell us how two masses will move around each other if nothing else gets in the way. But there is still so much we do not truly feel in our bones. We don't know how common certain kinds of collisions are. We don't know if everything we see in these waves fits our current picture of the universe, or if some of them will refuse to match, like a sound that doesn't fit any instrument we know. If one day we hear a ripple that doesn't make sense, that will be a special kind of moment, a cosmic misfit, a note out of key. It might mean we've found something new, a different kind of object, a new behavior of gravity, a sign that our map of reality is missing a whole region. I think I would feel the same mix of fear and joy that someone might feel if they heard a voice calling their name in a forest they thought was empty. Under all this, there is a quieter, more personal feeling that I can't quite shake when I think about space-time ripples from cosmic collisions. It's the feeling of being temporary, but not pointless. On human timescales, we are here for a moment. Our lives are short compared to stars, tiny compared to galaxies, nothing compared to the age of the universe. Sometimes that thought feels heavy, like a weight on the chest. But then I remember the waves. When a collision happens, the waves it sends out do not stop. They grow weaker with distance, yes, but they continue. If nothing blocks them, and almost nothing does, they travel across the universe, affecting every point they pass, even if only by a tiny amount. They change the distances between objects for a moment. They leave a faint passing mark on everything. In a way, our lives are like small collisions. We move through the world, we meet people, we love, we hurt, we help, we leave. We bump into each other, not always gently. And like gravitational waves, the effects of those collisions spread outward. A kind word to someone at the right moment might change a choice they make. That choice might affect another life, and so on, until far beyond anything we can track. The echo of that one small kindness touches someone we will never meet. The same is true for harm, for neglect, for cruelty. Our actions ripple through social spacetime. We don't feel most of these ripples. We don't get to see their full path, but they are there, moving through the network of human lives, nudging paths, stretching and shrinking possibilities. We are not isolated points. We are knots in a fabric. When I think of the universe this way, as a web of ripples, some in actual space-time, some in the softer space of human connection, it makes me want to move more gently. To be aware that everything I do sends out waves, whether I intend to or not. That my existence is not just a dot, but a pattern. There is also the mystery of what lies beyond these waves. We know that gravitational waves travel at the speed of light. That means they are bound by the same rule as light. There are parts of the universe we will never hear from because they are too far away, receding faster than their signals can reach us as space expands. Those regions are like rooms in the cosmic house whose walls are forever sealed to us. But even within the part we can, in principle, observe, there is more than we will ever fully map. We listen to a handful of collisions now. One day, we might listen to thousands, tens of thousands. The sky, in gravitational waves, might become crowded with events, overlapping like conversations in a busy cafe. We will need new ways to separate them, to pick out one voice from another. Somewhere among those voices, there might be clues about dark matter, about how fast the universe is expanding, about whether gravity behaves differently on the largest scales, about the true shape of space-time. But even if we solve many of those puzzles, I suspect something will remain beyond our reach, some aspect of reality that refuses to be fully captured. And strangely, I'm okay with that. The unknown is not just a problem. It's also a space where wonder can live. If we knew everything, there would be no more night walks with our necks craned back, no more late hours in front of faint screens waiting for a signal, no more soft questions whispered into the dark. Right now, somewhere out there, two black holes are spiraling closer. They might be circling a few times every second, or maybe once every hour, depending on how close they are. Their orbits are decaying, giving up energy to gravitational waves. Those waves are already on their way to us, racing through space, carrying the story of a future collision that has not yet happened in our time, but has already shaped the shape of space-time between there and here. One day, perhaps years from now, perhaps long after we're gone, those waves will pass through some detector, maybe a more advanced one than any we have now, and a small chirp will appear on a screen. Someone will see it. Someone will smile. Someone will think, there you are. I like imagining that. It makes the universe feel less like a cold machine and more like a place where events and observers are gently entangled, each influencing the other, even if only by deciding to look, to listen, to care. When I sit in a quiet room now, feeling the stillness around me, I remember that it's not truly still, that somewhere, far away, cosmic collisions are shaping the gentle, passing ripples that move through me as I breathe. I can't sense them with my skin or ears, but I can sense them with my mind, and somehow that feels almost as real. The thought has a texture, like soft cloth between my fingers. It has a taste, too, a little like cold metal in night air, sharp and clean. We are small, yes. But we are not outside the universe, looking in through a window. We are woven into the same fabric that bends and ripples when black holes meet. The atoms in our bodies were forged in stars, maybe in supernovae, maybe in collisions of neutron stars. The gold on a finger, the iron in our blood, the calcium in our bones, all of it born in violent events that sent waves through space-time. We are, in a very real sense, the stable shapes that formed after those waves passed. We are what the universe looks like when its collisions have had time to cool and settle into new forms. And now, with our brief lives and fragile tools, we are beginning to listen back, to hear the echo of the events that made us possible. It's like slowly becoming aware that the lullaby you've always heard in the background was sung by the very same universe that gave you a voice. As I speak these words, more ripples from other collisions are on their way, crossing dark spaces between galaxies, passing through silent dust clouds, slipping through planets and stars. They will arrive when they arrive, on no schedule we control. We can only wait and watch and keep our instruments and our minds ready. In that waiting, there is a kind of peace, a trust that the universe is not empty, that it is full of events we will never see but can still feel in faint, indirect ways. In the end, space-time ripples from cosmic collisions are reminders that nothing is truly alone. Every massive movement, every crash of giants reaches out across distances that seem impossible and touches everything, however gently. We, too, send out waves in our own small way, through our actions, our words, our choices. Most of them fade quickly, some of them travel farther than we know. Maybe our place in all this is not to control the waves, but to become aware of them. To live knowing that we are part of a universe that vibrates with memory. To understand that even in our quietest moments, when we feel most still, we are riding on an ocean of invisible motion, shaped by collisions that happened long before us and will continue long after. And as we float there, between past and future, between distant black holes and the ground beneath our feet, we have this one small, bright gift, the ability to wonder, to sit in the dark, listen to the silence, and imagine the ripples passing through us, carrying stories from elsewhere, reminding us that existence is not a fixed thing, but a dance of waves in a fabric we are made of and will someday return to. In that sense, every breath you take is shared with the stars. Every heartbeat is kept time by the same space-time that trembles when galaxies collide, and every thought you have is one more gentle ripple in a universe that is still, even now, learning its own song.